Good morning, everyone. This is Yash. This is from Advait Home Tuition online lecture series. Today, we are going to study about class 10 science. The name of the chapter is Chemical Reactions and Equations. The first lesson starts with the chemistry. Okay, now if you see the chemistry, let's see what we have. This one: carbon, hydrogen, nitrogen, oxygen, and sulfur. Those are the names, numbers of the molecules which you can see clear. Don't try to read what its name. It is simple name Tatin, which is a protein. It has the big chemical formula. But are we going to study this? No. What we are going to learn is this: how the resins get formed. So much yummy. How our stomach is full, and how to do maths in the chemistry. That is RHS and LHS. These are the simple things which you are going to learn in this chapter. Remember, quite concentrate one chapter at a time. So let's do it. Okay. The first instruction from my side is keep the book with you, or at least read it before the video or after the video. That will be much more helpful for you. Okay. Let's start. This is me, I think so. Yeah. Let's go for the page number 1 of the chapter. I will go with the page wise so that you won't get distracted and I also don't get distracted. On the page 1 they have given simple chemical reactions like the milk is left in the room temperature during the summer, specifically during the summer. What happens? Ask your mother, she will tell you how the milks get deteriorated. Then iron, tawa, pan, nail, anything you can see onto the ground or anywhere which has been kept in for so many days, it's got exposed to the humid atmosphere. And what it happens? The corrosion. What's going to happen to the corrosion? That's what we are going to see in this chapter. So keep that in mind. Grapes get fragmented, right? Then we get resins, obviously. Also, there is a pizza, which is also an important thing. How that is made, that is also one kind of a chemical reaction. You cook the pizza, then it get melted and it get mixed like that kind of things. Also, when it goes to our body, still there are chemical reactions that you have to keep in mind. There are chemical reactions when it get digested in our body. Okay, we get the verb. Then the final but not least, since we born to we die, there is always a reaction happening in the body, that is oxygen is get converted into carbon dioxide and we give that out. How that thing happens? That is also one kind of a chemical reaction. So yeah, there is a pizza, so keep that in mind, and resins also. So some interesting parts in this book as I can find. What are the effects of chemical reaction? That is what we are going to see the next. As we have seen, there are so many uses of the chemical reaction. Then what effects does the chemical reaction cause? That we have to study. First is change in state, then change in color, change in evolution of gas, and change in temperature. Now, there are different kinds of states available. As we know, solid, liquid, and gas. There are different colors available. That's also kind of examples. We have to just remember this. What are the different things? Then there is also evolution of gas. Many times in chemical reaction happens, there's some kind of gas, some kind of vapors passed through. That's all kind of a gas. Also, some reactions make change in temperature. Some increase the temperature, some decrease the temperatures. That is called a change in temperature. These are all are effects of a chemical reactions. Keep that in mind. Okay, let's begin with the first example which has been given into your book. Okay, the magnesium ribbon experiment. If you see the book, on the very first page of this chapter, there is a one example or the drawing has been given. That has been, there is a burner which is burning. There is a magnesium ribbon has been placed, and this magnesium ribbon has been burned from this burner. Okay, what we have got here is magnesium oxide. Now, where does this oxygen come from? It came from the air which is surrounding. Always there is oxygen, there is a nitrogen. Mostly oxygen is most reactant. Okay, it is quite reactive with all the chemical reactions in the world. So in this section we see this magnesium and oxygen both are reactants. They both react with each other, and this entire magnesium oxide is a product. What is it? Product, because this is formed because of this reaction as we give him heat. Just keep this in mind. For this I have given one video into the description. Just check that out. That same experiment has been shown over there. Now every time magnesium, oxygen, magnesium oxide, or the Titan formula, there are so many big things are there. So what's the best thing to write it down? It's the chemical equation. So scientists, one of the senior pillars of our department has been divided some equations of the chemistry. How those equations are formed? There is LHS, there is RHS, as I said earlier. On LHS there will be always reactant, and on RHS there will be always product. Remember this. Here the LHS side we found magnesium and oxygen. On RHS side we found magnesium oxide. Okay, those are written in these symbols with the coefficient. Now what we have done is from where to where the reaction goes. That is also one kind of important thing. So we can see magnesium plus oxygen, which forms magnesium oxide. So this arrow will reach into the between them. This kind of a chemical reaction we have to write in every aspect. Okay, don't forget this. The plus symbol is the simplest thing. I'm not going to interested to explain that one. We have to learn the different things. Again, there are so many things are going to be coming. Now how to write the chemical equation. This is another example which has been given into your book. That is zinc plus H2SO4 will go to the zinc SO4 plus H2. LHS side and RHS side. Zinc plus sulfuric acid has been given. On the RHS side we get zinc sulfate plus hydrogen. Hydrogen get released, so gas get released. Look at the numbers of molecules. Zinc 1. H is 2 molecules, sulfur is 1 molecule, and O is 4 molecule. This kind of a chemical reaction. Now chemical reaction in this case is only this. This is the chemical reaction. Okay, this is how you have to write it down. Okay, now if you see the next, they have given then another example, which is ferrous plus H2O, that is going to be ferric oxide, and hydrogen gas is released. In this chemical reaction, if you see carefully, there is always LHS and RHS. There is no doubt about that. Number of atoms in the reactant, suppose we goes for the ferrous, then we get the 1 atom. On RHS side we get 3 atoms. Hydrogen there are 2, but on the oxygen side there is a 1 atom, and here are the 4 atoms. So there is something mismatch. What is that? That's what we are going to study. These are the obviously chemical molecules which I have tried to show. Why I show these molecules is, keep in mind, these molecules are so much tiny. This is the equation which has been given for the simplification of the understanding of the chemical equation, not for the you guys, but to the scientists as well, to the everyone who is using the chemistry. Because tiny molecules, and we are not able to pick 1 molecule, 3 molecules, or even 10 molecules. There is always a solution, or there is always a large quantity of the amount. So the basic thing is that when ferrous and H2O will mix, it will always go for the ferrous oxide. But how much quantity it will produce, that we don't know. So for that, we have to match LSS to RHS so that we will get the proportion of how much it will be produced. So we have to match those. So if there are 3 ferrous atoms in this side, so there should be 3 on this side as well. So we multiply this one with 3. So we get 3 ferrous and 3 ferrous here this side. Now 2 are already matched. Now we have to match only oxygen. Okay, let's see what happens when we go for the oxygen. We made the oxygen 4, so we have to multiply oxygen 4 times here. So this oxygen is bit okay, there are 4. But if you see the hydrogen case, hydrogen has become 8 because this 4 multiply with this 2. So this become 8 and this side remains 2 because there is no multiplying factor over here. So obviously hydrogen gets angry. Let's see what happens next. We have to make this 8. So we had said 4 hydrogens over here and see every equation has been get matched. So in this case, if we get 3 ferrous, 4 H2O, then we get 1 ferric oxide and 4 atoms of hydrogens. This equation, remember, is called as a balanced equation. Both sides are okay. This is called as a balanced equation. So when the scientists will check the formation on this one, they will know how much quantity of hydrogen will get released and how much quantity of ferrous oxide will get released. That kind of way proportion has been decided. Okay. But this was the initial equation. Why this was the initial equation? Why this is important? Because this is skeleton equation. Skeleton means basic equation, which gives you the complete idea that what is the product and what is the reactant, not the quantity. Okay. This reaction is also an unbalanced equation because why? This was not balanced. As you can see, we have done it balanced later, but before that it was unbalanced. They were not same at all, the atoms. Okay, so this was an unbalanced equation, and then after some times we made it balanced. This is the complete equation, not the complete, there are a few things which we have to write down still, but this is the complete balanced equation. If you go for the next one, as we can see, there is someone came to just say yes, this has came in balanced. If you go for the next one, the changes in the physical state after you get for the complete equation, you have to always remember chemical equations always cause the change in the states. You can see there is a gaseous state, there is a liquid state, there is a solid state. You know those 3 stages. There is a 4th one came, that is aqueous. Now aqueous is the reactant and which is present in the water, present in the form of solution in the water. There are many kinds of materials or many kinds of elements which are always present in soluble in the water for the safety and for the convenience purpose. So we don't have to go into that which are those and why are those and what quantity. Those are for the PhD students, not for you. But remember, there is an aqueous condition is also there. So that same equation which we have shown here, which was earlier we balanced, we can see the ferrous was in the solid form, the H2O was in gaseous form, H2O is in liquid form, but here it is in gaseous form. That means it was its found of steam. We get ferrous oxide, so it get oxidized ferrous, so it was again solid, but H2 was gas. For this also I have given one, I think so, there is a link. Now chemical reactions condition. What are the conditions in which chemical reactions takes place? First, the temperature. Means you burn it, so you increase the temperature. Okay, you put the pressure. Many chemical reactions happens due to the pressure. If you put some kind of a pressure, then there is a change in the states of the reaction. They get reacted. Catalyst. Catalyst means what? Catalyst means putting any other substance who act as a catalyst between the reaction that takes place. Okay, now we have to mention these reactions with that one. If you have put it pressure, then put that thing above the arrow. at what was the situation and how this reaction takes place. That's the simple thing which we have to do. If there is sunlight, then you have to write down there is sunlight and there is a chlorophyll. That equation is quite big, so I didn't mention it here, but you have to remember under what situation that reaction takes place, that position has to be maintained there. Now there is a final topic of this chapter, that is types of chemical reactions, which we are going to study here. The first type of chemical reaction is a combination reaction. Now what happens in the combination reaction? We know when two or more things combine with each other, that is combination reaction. Okay, there is a decomposition reaction, means one thing is bigger and we decompose it, we separate it, that is decomposition reaction. The third one is displacement reaction. What happens in displacement reaction? One element came, it displaces someone and takes his place and he goes out, that is displacement reaction. And the last one is oxidation and reduction. Oxidation means gaining oxygen, reduction means reducing oxygen. These are the simple terms. Don't make it official कि हाँ ये बोला था तो ये लिख दिया तो मार्क्स मिलेंगे. No, this will not happen. You have to keep that in mind. First, we will study the combination reaction. Here is a quicklime which has been mixed with the H2O, that is water. We get slack lime and also we get heat. So you can see two or more particles has become only one. They were one, there is a two, and only one element we get. The single product is formed from two or more reactants. It's called as combination reaction. Sorry, exothermic reaction. What will make the exothermic reaction happens? Single product is formed from two or more reactants. Exothermic reaction means if heat is generated, then that is exothermic. The thermal will exhaust the heat. That is exothermic reaction. Few other examples are there: rice, potatoes, and breads contain carbohydrates. Remember, carbohydrates or these all are chemicals. Even potato is chemical. We all are chemicals if you can write the formula. So these carbohydrates are broken down to form the glucose. This glucose combines with oxygen in the cells of our body and provides energy. So carbohydrates will give us glucose and energy. So this is also one kind of exothermic reaction. That's the reason when if we eat after the dinner or after the lunch, we feel some kind of heat or energy get generated. Okay. The next point is the decomposition reaction. What is happening in the decomposition reaction? When there is a one big man and it gets decomposed in two or more, that is decomposition reaction. So if you see ferrous sulfate we have, which has been heated, only if heat has been provided, we get it breakdown. Ferrous oxides, sulfate oxide, SO2 and SO3. Okay, sulfur dioxide, sulfur dioxide. Again, there is same thing. Limestone has been provided, which has been heated. We get the quicklime. Okay. See, these are the simple examples of the decomposition reaction. We don't have to go inside the much deeper what kind of. We just remember these few reactions. Decomposition means one to many. There are other decomposition reactions like lead nitrate has been there, which is also again heated, which goes to lead oxide. This is important option. These both are the gases. So those are the only byproduct we can say. Main product is this lead oxide. Again, there is silver chloride. Again, it was placed in the sunlight. We have the image also in your book, which goes to silver and chlorine. Keep that in mind. This is the displacement reaction. I had told you earlier, one product gets replaced and another product sits there and he goes free. Most of the time it's copper. You see this one. Most of the time it's copper for our syllabus, not all the world. When there is a 4s, he replaced him. When there is a zinc, he replaced him. Same thing here. Lead. You have to keep that in mind. So everyone comes to his place and copper gets free. Copper gets free. That is the simple as a displacement reaction. Keep that in mind. Now this SO4 means sulfate, this Cl2 means chloride, there's nothing more. These are the common elements we will see in future chapters. Okay. That is displacement reaction. There is nothing more to explain, I say. As you can see, there is a copper guy who is always get replaced, unfortunately. Double displacement reaction. Now, some people are not interested. If they say you are going to replace me, I will replace you. Same thing happens here. Double displacement. Thus the sodium guy has gone with the chlorine guy. Like this way. So this barium guys say, if you go with the chlorine, I will go with the SO4. So he goes with the SO4. So sodium sulfate has become sodium chloride and barium chloride become barium sulfate. That's the simple thing. That is single displacement. This is double displacement. That's the only thing which we have to remember. Now the last one we can say oxidation and reduction. Suppose there is a copper and there is oxygen. You heat it, it becomes CO, copper oxide. What happens over here? They gain the oxygen. In the same way, this guy has been run from the hydrogen gas. Again the oxygen goes out and we get copper separate and H2O, that is water. What happened in this case? Reduce the oxygen, lose the oxygen. This is the oxygen with copper and this is the copper without oxygen. So he lose the oxygen. Keep this in mind. Forget about the rest. This copper was with oxygen. Here he left the oxygen. Here he was single. Yeah. He gets the oxygen and they become combined. So he gained the oxygen. That is oxidation, that is reduction. Okay. Oxidation you gain, we attached with the oxygen. In the case of reduction, you lose the oxygen. There is also twice, that is redox. If someone is going to lose the oxygen, I am going to get that. So, in this case, you get reduction plus oxidation, that is a redox equation. Both losing and gaining oxygen takes place. Oops, there is a spelling mistake, sorry for that. Okay. Now the final topic of today's lecture. That was the final, but this is the simple final. Don't make it too much. It is a final investment. There is a corrosion. Everyone knows what's the corrosion, what it forms on the car bodies. We can see on the bridges, on the iron railings, ships. There's everywhere there is a corrosion. Especially it happens with the iron. Many products have been made from the iron, so they get corroded. What happens when the metal is attacked by the substance around it, such as moisture, acid, etc. Moisture and acid, it gets contacts with the metal. It is said to be corrode, and this process by getting corrode is called as a corrosion. That's the only thing. When any metal gets contacted with the moisture and acid, it gets corrode, and this process is called as a corrosion. Right? Same thing, the next procedure is there. Now, final topic, so you must not come here. Rancidity. Same thing as the metal, there is the same thing happens with the food, fats and oil. Okay. Same, it gets with the moisture, it oxidizes or something like that, and it start to get rancidity. That's the reason our beloved chips are kept in the nitrogen gas. Yeah, so that it will not get attacked by the oxygen or the moisture. Moisture means some kind of a water droplets or minute water. My water means H2O, so there is oxygen. So this nitrogen will keep it out, and nitrogen will not react as quickly as an oxygen or H2O. So it's get fresh as always. Okay. So to get touch with the oxygen or moisture, and there is no question of rancidity. This is the end of this chapter. I request you to again read the chapter into the book. Keep that reading. If you have some doubts, message me here. Okay. Kindly like and subscribe the channel. Stay blessed and stay tuned. Thank you.